In this video, we will be talking about triple bonds and the sp hybridized orbitals. Atoms with two electron groups belong to the family called the linear shape. The bond angles for linear shaped molecules are 180 degrees because they fall along a line. Atoms use hybrid orbitals for the sigma bonds or lone pairs and use non-hybridized p orbitals typically for pi bonds. In an sp hybridized orbital, you're taking a single s and a single p, hybridizing them together to get two hybrid orbitals. Because you left behind two p orbitals that you did not hybridize, you still have those two unhybridized p orbitals. These unhybridized p orbitals in a lot of sp configurations are going to be part of pi bonds. The shape of the sp hybridized orbital is as follows. If we take an s orbital, mix it with a p orbital, then you have to have hybridized orbitals that lie completely along the x-axis. We're not adding any y components, and so the orbitals cannot stick up diagonally in the y direction. We're not adding any z component to it, so they can't really have any z component direction. Instead, they must lie completely along the x-axis. We have the two lobes from our px and the spherical shape from our s. So we're mixing two orbitals together. We should get two orbitals back. The orbitals look like this. When they are sitting on top of each other, the resulting structure looks much like a p orbital, but it is actually two orbitals lying somewhat on top of each other. You have your one sp orbital here with a small lobe on the other side, and your other sp orbital over here with a small lobe on this side. Because the two orbitals are lying along the x-axis, that enables a free use of the space directly above, below, as well as in front and behind your sigma bond. Those locations above, below, and in front and behind are used by two sets of pi bonds. So when we are creating the sp hybrid orbital, we're using one s along the x-axis, which we are calling the internuclear axes, but we are not using the py or the pz orbitals. So we can then mix the pz orbital from one carbon in this case with a pz from the other carbon to give us a pi bond that take up space in front of and behind our sigma bond. And then your py is here for one carbon and the other one is over here. Your two py orbitals can then combine to give you a second pi bond above and below. So in total, you have two sets of pi bonds above, below, and then in front and behind for two sets of pi bonds, and then a sigma bond. So this is how you get a triple bond. You have three different bonds, a sigma bond and two sets of pi bonds. In order to do that, you need to use an sp hybridized orbital.